This video is going to help with the factoring problem that you needed to do for the summer project. But before we do that, I just want to take a quick look at another problem. In algebra, you would have problems like this. 3x plus 2 equals 23. And you would be told to solve that problem, and so you would isolate the variable. You'd subtract 2, whatever you do to one side, you do to the other side. Add these two things together, you'd get 3x equals 21. Divide by 3, and x equals 7. That's fine, and this tends to be the approach that you take to solving equations. Now, here's where it differs. Let's say we have a problem like x squared minus 3x minus 10 equals 0. This is a quadratic equation. It has an x squared term. If we add 10 to both sides, then we've got this thing on the left. And there's no way of isolating the variable. So when you have a quadratic, you need to use a different approach. So here's what we're going to do. There's a couple of different approaches. There's factoring, there's using the quadratic formula, which you haven't learned yet. So for our purposes in this class, when you have a quadratic, an x squared term, here are the steps that you need to take in order to solve a quadratic equation. Set the equation equal to 0. This one is, so our first step is done. Factor. Okay, we're going to have to do that. Then set each factor equal to 0 and solve. All right, so the first step is already done. Set the equation equal to 0. Now the second, factor. All right, how do we factor this? Well, this is of the form x squared plus bx plus c equals 0. Our quadratic equation here has an a, but that a equals 1. And that's how, when the a doesn't equal 1, this method's not going to work. But most of our problems in this class this year, the a will equal 1. All right, so when we have the a equal to 1 here, we need to find the factors of this quadratic. So we have to ask ourselves, what numbers? We need a pair of numbers that multiply to c and add to b. All right, let's go back to our equation here. We're looking for a pair of numbers that multiply to negative 10 and add to negative 3. X squared minus 3x minus 10 equals 0. So let's think of numbers that multiply to negative 10. Negative 2 times 5 equals negative 10. 2 times negative 5 equals negative 10. Negative 1 times 10 equals negative 10. 1 times negative 10 equals negative 10. Which of these pairs of numbers add to negative 3? I think if you look at this pair here, you can see that 2 plus negative 5 equals negative 3. Therefore, these are our factors. So you give yourself two sets of parentheses, x, x, and then our factors are plus 2 minus 5. Okay, so again, to solve a quadratic, it has to equal 0. Then we factor. And our third step is to set each factor, this is a factor, equal to 0. This is a factor, equal to 0, and solve. Subtract 2, x equals -2 is one solution. Add 5, x equals 5 is our second solution. Okay, let's go ahead up and I'm going to do a couple of checks here. I want to check my factors. Did I factor it correctly? To check our factorization, we FOIL x plus 2, x minus 5. Okay, so I'm going to look at my first terms, and multiply them, and I get x squared. My outer terms, here they are, that's my first terms. My outer terms, x times -5 is -5x. My inner terms, right there, 2 times x is going to be 2x. And finally, my last terms here. 2 times -5 is -10. If I have done everything correctly, these should be like terms that I can combine, and I get x squared minus 3x minus 10. And so my factors have checked. Okay. The other thing I can check here is I can actually check my solution. So x equals -2. Let's put -2 back into the original equation. -2 squared minus 3 times -2 minus 10 equals 0. -2 squared, 4, minus 3 times -2, positive 6, minus 10 equals 0. 10 minus 10, 0 equals 0. Check. And then I can check my second solution as well. I think I can squeeze it in here. 5 squared minus 3 times 5 minus 10 equals 0. 25 minus 15 minus 10 equals 0. Therefore, 0 equals 0. Check. All right, let's take one more example here. X squared plus 6x equals -5. Okay, so the first thing we have to do is get this set equal to 0. So I'm going to add 5. Whatever I do to one side, I do to the other side. And I get x squared plus 6x plus 5 equals 0. Next, I'm going to factor. I need numbers that multiply to 5 and add to 6. 1 times 5 equals 5. 1 plus 5 equals 6. Therefore, those are my factors. I'm going to give myself two sets of parentheses. X plus 1, x plus 5. I have now factored it. Now I have to set the factors equal to 0 and solve. X plus 1 equals 0. X plus 5 equals 0. Subtract 1 from both sides. X equals -1. subtract 5 from both sides, x equals negative 5. Okay, let's do one more. X squared plus 12 equals 8x. All right, now I want this in standard form, so I want x squared, then I want my x term, then I want my constant. Minus 8x, I'm going to squeeze it in there. X squared minus 8x plus 12 equals 0. I need numbers that multiply to 12 and add to negative 8. There's quite a few factors of 12. Now, since they have to add to a negative, but they have to multiply to a positive, both factors are going to be negative. Negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4. I think most of you can see right here, these are the two factors. They're going to multiply to 12 and add to negative 8. Give myself two sets of parentheses. X minus 2, x minus 6. Set each factor equal to 0. And solve. Add 2, x equals 2, add 6, x equals 6. Okay, and that's a quick review of factoring. When the coefficient of the quadratic term is a 1, this method will work.